Hi, thank you for joining us. My name is Eric Rosenbaum. I'm the Chief Technologist in Red Hat's Global Financial Services practice, and I'm here joined with Josh West. Josh, can you introduce yourself, please?
Hi, I'm Josh West. I'm the Chief Architect for North America Financial Services. So we focus on the top 35 major banks, Wall Street banks, Canadian banks, as well as a small bit of hedge funds as well.
Excellent. Josh, I mean, both of us work with, you said, North American banks. I work with the global banks. So we have a lot of conversations with senior executives, both in the line of business as well as CTOs and CIOs. With respect to trading, what are you seeing and what are the conversations you're having with these individuals in terms of challenges they have, how are they solving for them, and how are they looking at the future of global markets and trading?
Yeah, well, first I'd say that much of what I've heard in the past was that people are trying to make trading systems faster. Burrow through mountains to get direct fiber to the markets and where they are,
Always the case.
arbitrage and otherwise. The speed of light. I think everyone is super close to the individual exchanges at this point. What we're hearing is that each individual firm is looking to be able to better respond to changes in the market faster. The diversity of different perspectives that might need to be built into their algorithms. So the main thing that I'm seeing is they want velocity of change and the ability to experiment with different models to be able to push them into these exchanges faster. Are you seeing similar things across your perspective too?
Yeah, I'm seeing similar things. Obviously, we're not speeding up, light. That we've got a lot of great technologists. We're not doing that. So, how do you iterate faster? How do you react better? If a quant's got a new idea about something that's happening in the market, and how you can react better, either for your own book or to service customers, how do you get that into production faster? I would say yes. The other thing that they're challenged with, I see and I hear from people, is power and cooling. So they're deploying these solutions either on-prem or colos, and they're constrained by power. So how can they do more with less power? How can they? Nobody wants to take a 42U rack and populate only half of it or a quarter of it. How can they be more efficient about packing that in? And from a perspective of operational resilience, I think that's a topic that's really picked up in the last few years, given supply chain constraints outside of technology. But the Europeans are very focused on how do I be resilient? How do I document that to regulators? I'm curious if you're seeing similar things, Josh.
Absolutely. I hear the word density quite a bit.
Okay.
I think floor space in colos is very limited. They want to be able to have more systems interacting on the exchanges, as well as more options to be able to support additional strategies. However, there's limited space that is that close to the exchanges. So not just the power, but the density of what they can fit into those racks is super important. And there's a lot of work going on in the chip manufacturers and OEMs and otherwise, such as CXL, which you and I are both talking to multiple vendors about, to be able to have more control of how memory is shared across NICs and chips and otherwise, to maintain that speed that's optimized down to the microsecond to nanosecond as well.
Yeah, great point. And I see also the idea of optionality in terms of GPUs, because there's two key vendors out there with GPUs. Do you want complete performance? Do you want performance per watt? Do you want cost per token? I think people need to be thinking about what metric they're interested in, and that metric for that use case may not align with a different use case, and you need to preserve optionality. So when you're picking platforms and you're making architectural choices, you're baking in the ability to do different things today in the future for different use cases.
I certainly see that, the various chip manufacturers and the work that goes into both things like FPGAs as well as chips and these high-speed network cards as well, can easily link someone to a very low level into the architecture of the hardware running under it. So certainly the ability to have more agility on how you're interacting with these very low-level controls, but also have some level of optionality is challenging. But that's something that many of us are focused on, and those are the conversations that I'm having is how do we maintain that agility, again, the major drive is velocity of change.
Mm-hmm.
Even opening up more people to be able to create these strategies for trading too. How do we make sure that if you're dealing with bit registers at a super low level, that makes it harder to be agile enough to change those strategies too.
But
Um,
there's also techniques, I think, if you go to containerization, for example, and this is a topic I have with a lot of people. If you go to containerization, you can get better density. Some numbers show 30% better. I've seen 60% in some isolated cases as well. You get better density, so that's affecting and improving your performance for cooling, for power, and so on and so forth. You have the ability to have better agility. Okay, you can have, say, a blue-green deployment, running things side by side, a little bit of flow over here. You're reducing operational risk. I mean, what other techniques are you seeing people employing to get to this better velocity, but at the same time reduced operational risk?
Yeah, I was getting to the same exact thing. So containers, as well as container orchestration, allows you to have that bare metal performance, still even get access to the lower level controls, everything from huge pages to CPU pinning, to pass through network
Numa as well.
NUMA as well. And some of the work that we're seeing around CXL and composable architecture, again, these things help you to have a more abstract control. Again, like you said, containerize those strategies and have a bit more agility and reproducibility of what you're doing,
Is
but
this
still tap into those advanced pieces.
is this theory, or do we have customers actually doing this in practice?
We have two major customers already using OpenShift and Kubernetes, very stripped down if you're optimizing um, for the speed and latency and otherwise. But we're still providing that ability to push out new containerized approaches, tapping into the bare metal capabilities. Our larger customer already has OpenShift stripped down, but deployed over, I think, 12 different markets and colos across the world. And these are passing through to, both do things that might be optimized for the microsecond, as well as passing through to FPGA devices as well.
Yeah, interesting, because we were at a Stack conference recently in New York City. We talked about OpenShift for low latency. And I think there's a lot of surprises that you can get the same performance characteristics as we do with RHEL with OpenShift, but gaining that ability to be more agile, more velocity, and so on and so forth. I think there's a perception out there that OpenShift means, or Kubernetes means, slower performance, but that's not necessarily the case.
I certainly feel like the impression from those that aren't already doing this work, they feel like something like Kubernetes or containers adds a layer of latency that just doesn't exist. So the concept that we generally try to describe is that a container splits a kernel up and still gives you access to those low level controls, whereas a virtualization layer adds an actual emulator layer that will add latency. So a lot of what we're doing is trying to have those conversations and produce materials, as well as, both you and I are involved in the performance benchmarks to show that there's parity in performance of bare metal to containers as well.
Because you still get support for, as you said, NUMA, CPU pinning, FPGAs, whether it's Mellanox, SolarFlare, or what have you, that support is still there. So you're not losing those performance characteristics.
Absolutely. I think the other piece is that many trading systems, there's so many complex components that need to be orchestrated to be connected together.
Mm-hmm.
Kubernetes is this natural event loop that takes the desired state, tries to match it with the current state. Basically, the way that people are writing these custom orchestrators, Kubernetes can do a lot more of that work for you, and still give you that control to do things like CPU pinning and isolate individual processes, and also make sure that one of those processes is running in a container can't break out and impact other services on that trading system too. So it improves the safety of running trading technologies, in case someone had gotten some of their custom orchestrators wrong in the past.
As well as you mentioned, kind of forward deploying these things in colos around the world. So that manageability is critical.
Yeah, I think the other, beyond just being able to stamp out these configurations and push out iterations where basically the entire software, the infrastructure that you're running these trading systems on is software defined. We can add that consistency with your back testing environment. You're probably not using these specialized devices like FPGAs in your back testing, but the process is going to look very similar if you're running it in OpenShift or Kubernetes in general. In your back testing environment, they'll tend to be much larger, where you're testing many different strategies, not against the live data coming through in the real-time feed, but in data that you're playing out the different scenarios and comparing the results that you can achieve.
That's important, because that's a conversation I had with a large U.S. hedge fund where they wanted to showcase, and their thesis was, if I can run the same environment for developers and for non-prod and for prod, then I'm more certain when the model, let's say, doesn't work towards what I expected it to do. It's not because, well, I ran version X here and version Y there and version Z there. If you can get the same implementation, the same environment across all these places, you're increasing your velocity, you're reducing your operational risk. But the premise was they wouldn't do it if they couldn't get the performance characteristics they needed in prod. We were able to showcase with OpenShift those performance characteristics exceeded what they expected. Therefore, they can, just have containers for their quants, and it just simplified the whole model.
Yeah, one of the major banks had stated very publicly that they're teaching traders to code and coder trade.
Yeah.
So that's important. How do you create an experience that people can test these strategies without necessarily knowing the low-level details of how a processor works? The people who understand the business and the markets and how they're shifting. I certainly say that I have a friend that is an analyst for one of the major analyst firms, and he's like, this market makes no sense. So it kind of speaks to what the traders are dealing with, that there could be a lot of black swan events or things that don't quite make sense, and you have to be able to test and iterate for what might be changing in a very dynamic way in the markets. Again, which speaks back to that need for velocity of being able to change your strategy.
It's correlations. I mean, and that's why it's very mathy, and that's why it makes a lot of sense. So, speaking about that, I mean, we can't have a conversation, we can't have a coffee talk without AI, of course. Okay, it's de rigueur. So, what do you hear from people with regard to AI, specifically in the trading space? I mean, we hear a lot of different use cases about call centers and this and that, but specifically in the trading space, either pre-trade, post-trade, or actually in the trading flow.
I think it depends on the kind of customer they're working with. I think there's large Wall Street banks, and then there's hedge funds. Hedge funds are doing things like sentiment analysis, and probably even using Gen AI to do summarization to understand the sentiment they see across the web, to impact their strategies in probably more real way. I think a lot of predictive machine learning. I mean, this isn't new AI; has been used for many years across trading already. Yep. For that statistical analysis.
Decade plus.
So I think the conversation usually comes down to what can operate, or what can you implement on GPUs that will act in a very repeatable way. Probably the wrong word, repeatable.
Maybe deterministic, is that the word?
Yeah, deterministic way. Because you don't want this learning model to change in ways that impacts you poorly. So you have to think about those controls. So much of what I do see is more focused on these deterministic kind of algorithms that can that might be machine learning driven to be able to impact these strategies. And I think the GPU really comes down to the volume of data that's passing through.
Yes.
The chips. A CPU is kind of like a Porsche. It can get you wherever you want, get you wanting to go fast, but you can't carry a lot of cargo. GPUs allow kind of a Mack truck or a super truck to move a lot of cargo at a given time and process those in a very fast way to get you to your destination. So as you have a lot of data that you want to process with that's flying at a very fast speed, GPUs are super important for those predictive ML models, potentially more for those Gen AI models that I'm sure we'll continue to get into the trading flows eventually too.
And do you need to think differently? I mean, do you have a different platform when you're deploying predictive AI versus Gen AI versus, traditional algorithmic programming, or can you run all of it within, say, OpenShift?
Again, that's kind of the beauty of containers, is that you can abstract away the underlying hardware. I mean, you can still use specific frameworks like CUDA from NVIDIA, but that will limit your ability to use other chips behind there too. So there's a lot of work going into how do we create frameworks that could use any potential chip and still get a lot of that deterministic performance as well as deterministic results from what you input and output that you get as well.
And investing in one platform that will allow you to do any of that, because times will change. There's a lot of different models, LLMs, for example, today, the Llama one open source, there's Granite, there's obviously OpenAI and so on and so forth. There's also domain specific ones. Bloomberg's got one, JPM has Doc LLM. So I think you're gonna be choosing different models over time, depending upon your use case. And I think you want that optionality to where to run it, which model to use, which hardware accelerator to use. And I think that's the place where the architects are going to have their work cut out for them to designing an effective strategy and a platform that, works today and as well as 6 months or, 2 years based on the level of innovation.
I've been at Red Hat for 18 years now. I'd say that one of those core things that we've always focused on is making sure that we provide that optionality. There's a lot of proprietary vendors or other vendors that are pushed to make one stack that is optimized for a subset of what's needed across the market. Red Hat's always been very focused on being a foundational layer that's compatible with a lot of these new innovations, as well as the variety of things you might put on top of that. So the work that we keep talking about these in the trading area is how do we bring these patterns and how do we expand these patterns that we have and drive our ecosystem partners to have that compatibility and control that you need for these very specialized use cases.
Good point. Is there anything else, Josh, we should talk about?
I guess I'm interested too. We said AI, but quantum as well. We're hearing a little bit of discussions around quantum and how that will eventually impact trading systems as well. Much of the focus today with quantum is on quantum safe encryption.
Yes.
And with disconnected environments, that especially in colos, you need to make sure that you're connecting to those real-time trading systems over a very secure link, and that the data can't be captured in process as well.
There's also interesting stuff of, algorithms coming out with regard to portfolio allocations. How can you do that more efficiently? Obviously, you can run through more models, then you can get a better model that you put into production. Interesting stuff there. And certainly in a hybrid world, because it's not going to be just quantum. It's going to be quantum as well as traditional computing. And how do you marry the two of them together to get, solving the problem? It's not all in on one thing. So fascinating area.
Yeah, I'm super interested. Of course, what I see today is a lot of the quantum safe encryption for these disconnected environments. And I'm hearing that I think it was this year that a lot more people are talking about quantum and how that might work into the early experimentation that people are doing trading today. But certainly an area I want to focus on and know very well going forward as well. And Red Hat has a lot of focus, particularly with IBM, but also other vendors as well in the quantum space too.
Yeah, we have a huge ecosystem.
Anything else, Eric?
No. I think this has been great. I always enjoy chatting with you and learning more and getting smarter, Josh.
Thanks. Always a pleasure to talk to you.
So thank you everyone for joining us. You'll get an email with some information. Reach out to Josh, myself. Happy to have conversations. We'd love to share our thoughts, our experiences, and learn more from you guys and how we can help. So thank you.